Hi everyone, this is Aruna, Assistant Professor, Department of Information Technology, SNS College of Technology. In my lecture series, today we're going to see about the computer architecture subject. In that, we're going to see about the introduction to the computer architecture. So before entering into the syllabus, first we're going to see about what do you mean by the computer architecture. So we will know the thing what is known as the computer means it is an electronic device to perform arithmetic and logical operation. We are using a computer. Nowadays, computer can be widely used in all the industries. So before seeing this thing, definitely we have to know about the storage unit because our processor, it depends upon these units. Definitely we have to know. So you're having a n number of units, storage units are available. One is a bit. It can be used inside the processor. 4-bit we can call it as a nipple, and 2 nipple or 8-bit we can call it as a byte, and 1000 byte we can call it as a 1 kilobyte, or 1024 byte we can call it as a 1 kilobyte. Similarly, 1024 kilobyte we can call it as a megabyte. Similarly, 1024 megabyte we can call it as a gigabyte. 1024 gigabyte we can call it as a terabyte. 1024 terabyte we can call it as a pentabyte. 1024 pentabyte we can call it as a exabyte. After exabyte we are having a zettabyte, yottabyte, brontobyte. These are the maximum storage available in our storage unit. The next thing is why we have to study the computer architecture. So what is the need over here is because a computer is an electronical device. Architecture is nothing but what is the internal operation, how the internal operation is working inside the processor, that going to deals with an architecture. So as a computer architect, why we have to study this thing? Because for IT, CSC and AML students, why we have to study this thing means definitely in any electronic device, we have to know what is the structure of our internal components. And also without just we are knowing only the internal component means what is that in each and every unit, how it can perform. What is the logic behind over that? That is a second thing for studying the computer architecture. That is a program to realize the logics. The third thing is because we are going from version to version. So when we are moving from one version to another version means if you want to have a more efficient, if it can have support more than this, for that only we are moving from one version to the another version. In this case, for running effectively in the real world machine, for that definitely we have to use the architecture. So while moving from one part to another part, definitely we have to know the better idea in our computer architecture. For that only we are studying the computer architecture. So this is a computer. This is the architecture. This is the internal components of our computer system. We will know this thing. So what is the internal part of this thing is that these are the unit present inside your processor. So this only we can call it as an architecture because it will have a fetching unit, decoding unit, execution unit, memory unit, and write back unit. So these entire unit only we're going to call it as an architecture. This is the internal logic. We are saying we are going to perform two number addition, multiplication, subtraction. It can be done over here. It acts as it look like a multiplexer, but it will perform arithmetic and logical operation. So inside your processor, similarly, you're having architecture like this. This only going to perform all our actions. So this is a definition of a computer architecture. So computer architecture is nothing but the concern with the structure and behavior of various functional modules, computer, and how they interact to produce processing needs of a user. Similarly, it will refer to the operational units and their interconnection. So then only we can interact with what is the need, that interior part of our system, that we can call it as a computer architecture. Computer is nothing but a fast electronic calculating machine which accepts digital input, process it according to the internal stored instruction or a program, and produce the result to the output devices. This can be done by the computer. So major thing in our computer architecture is, so initially in a C or any other programming language, we can call it as a high level language. Machine will know only the machine level language. So intermediately your compiler can convert your high level language into an assembly language. After, by using an assembler, it will convert the assembly language into a binary language. Again, your binary code is converted into a hexadecimal code while storing the data into the processor. So this is the how a language can be converted to the another form by using a compiler and assembler. So inside the thing, we are having a 4 stages. One is a fetching stage. Inside the architecture, we are having a 4 stages. One is a fetching. This is the next instruction is to fetch it from a cache or a RAM. The next thing is a decode. The instruction are decoded into a form the ALU or functional processing unit can understand. Based on the need only we are decoding our data. The third stage is the execution stage. The instructions such as ALU or processing unit performing a computation or carried out. The fourth stage is a storage data. The data and the result from the instruction execution are stored in the register or a RAM. So these are the 4 stages available in our architecture. The next thing is the types of computer. Your types of computer can be classified into 3 parts. One is based on size, based on mechanism, and based on purpose. Purpose is generally we are having a 2 purpose, general purpose and special purpose. Based on the mechanism means we are having a 3 mechanism: analog, digital, and the hybrid. Based on the size means super, mainframe, mini, micro. Micro we are having a desktop, laptop, laptop. These are the various types of a computer. So your computer, mainframe computer is a higher capacity and it is much costlier and largely used by big organization where the people can simultaneously accessing the data. For that case only we are going for a main computer. Supercomputers are fastest and also more very expensive. Can solve up to 10 trillion individual calculations per second. For that only they are going for a supercomputer. Workstation computer, high-end and expensive one. It is exclusively made for the complex work. So these are the various types of computers. So you're having a personal PC, Apple Mac, laptop computer, tablet, smartphone. These and all can be used based on the purpose, based on the application where we are using. Normally our generation of the computer can be classified into 5 generation. First generation, second, third, fourth, and the 5th generation. So these are the various timeline of your generation. Nowadays we are in the 5th generation. Initially, the hardware can be used in the first generation is a vacuum tube. In second generation, it can have a transistor. This is on and off switch like that can be called it as a transistor. Millions of transistor can combine together that only formed as an integrated circuit. Millions of integrated circuit can be combined together. We can call it as a microprocessor. The microprocessor, so many microprocessor can be used inside the thing is called as a artificial intelligence. Nowadays we are in the 5th generation. This is the levels of a computer hierarchy. Initially we are having the inside the processor we are having a digital logic. For controlling the digital logic we are going for a controlling unit. Either we can go for a microcode or a hardware control. For working this thing that definitely we have to go for an architecture that can be called it as a machine. We are need the instruction set architecture for executing any instruction. Definitely for executing this machine, definitely we need the system software. That is operating system. Without the operating system, we can't able to do anything. Library code alone, this all needed for executing any program in a machine. So if you are having only operating system, can you able to execute? Because we know the high level language, machine will know the machine level language. Intermediate language, that is a assembly language. So we are converting our high level language into an assembly language by the compiler. After the compiler, again assembler can convert your assembly language into a machine level language. This is the human understandable language, high level language, all programming language, we can call it as a high level language. and also this can be executed by the user. So the entire thing for executing a program, definitely we have to come across these 7 levels is needed for executing any type of a program or anything. Thank you for watching my video. In my next video, we're going to see about the functional units.